Welcome to Accelerated Math 108, Module 11.2, Solving System of Linear Equations by Substitution Methods. So in the previous lecture video, we talked about when we graph two lines, they can intersecting at one point, and that point of intersection will be my solution. And we can also have two lines that are parallel with each other, where we have no solution, or the two lines can be exactly the same line where they're intersecting everywhere. That means they have infinite number of solutions. So in this lecture video, we will also run into the three scenarios. We're just going to look at them from the substitution perspective. So substitution method is one of my favorite methods when it comes to solving system of linear equations. I always use this method when I see a one variable out of the four has a coefficient 1. So the overall steps is number one, solve one of the equation for one variable first, and the one variable that you're solving for has a coefficient 1 because that will avoiding end up with a bunch of fractions. Then we're going to substitute the resulting expression into the other equation, solve for this new equation if possible, and then substitute back into the original equation to find the value for the other variable. So let me show you real quick. So here I got two equations. I'm going to label them as equation 1 and equation 2. All right. So if you look at my equation number 2, all the coefficient in the constant term is divisible by 3. So what I'm going to do is rewrite this system of linear equation as 2x plus y equal to -1. My second line, or my second equation, every term is divisible by 3. So I'm going to have -x plus y equal to 8. All right. So two variables, two equations. So I got four different variables here. Three of them has coefficient 1. So I'm going to select just one of them to solve. As for my step number 1 here, solve one of the equations for one of the variables. So I'm going to pick this one. Okay, I'm just picking any one out of the three. I'm going to pick this one. Solving for y. Solve for y in second equation. All right, this is a very important step because to get y by itself, I will need to move the -x over, so I get y equals, okay, -x come over, become positive 8, still positive 8. So now this is y equal to x plus 8. I'm going to call this equation number 2 prime. That means this equation comes from my original second equation, and I worked on it one time. So I'm going to try to keep a track as we go along. All right, I said this is a very important step because once I solve for x, this equation is where I come back to get my y by itself. So now what I'm going to do, step number 2, is sub my y equal to x plus 8 back into the first equation. And what am I substitute for? I'm substitute for y because I solved for y here, so I'm going to substitute into my first equation. Don't substitute back into the second one because this equation comes from the second equation. So when I substitute back into the first equation, my 2x sub, I'm going to write it down, okay, sub 2 prime into the first equation. So my first equation normally says 2x plus y. Now the plus y, I'm replacing the variable y with these two terms, x plus 8, so I will put them in the parentheses. So whenever I substitute two terms for one thing, I always put them in the parentheses for protection from just in case this plus sign is going to be a negative, or there's a coefficient right here where I got to do a distribution. And that's equal to -1 still, right? So because this this is what my first equation originally say. So I'm just basically replacing the y with x plus 8. That's why the first step is solving for one particular variable. Now I'm just going to solve this equation. So my second term, okay, has parentheses. So this is positive 1 that will do the distribution. So 2x is still 2x, positive 1 times x, positive 1x, positive 1 times positive 8, still equal to negative 1. So basically the idea is, since I got two different variables, okay, I substitute one of them into one of my equations, so I can only end up with one variable, one equation. So combine like terms here, that will be 2x plus x is 3x. At the same time, I'm going to move my positive 8 over. That become negative 8 on the other side, which is going to be negative 9. Negative 1 minus 8, positive 8 come over, become negative, so that becomes negative 9. Divide both sides by coefficient 3. My answer, x equals negative 3. So now what do I do with this? Because I got to have two answers, because the point of intersection on the two lines has an x value and a y value. So now I'm going to sub my answer, x equal to negative 3, back into any one of the original first two equations, the one I simplified, or the second prime. Because the second prime here already say y equal already. So that's the one I'm going to go back to. So I'm replacing this x with negative 3. So my second prime normally says y equals x plus 8. Now you will say negative 3 plus 8. So my answer, y got to equal to positive 5. All right. So I have one solution. And my point intersection is going to be negative 3, comma 5. Okay, make sure y'all don't write these two numbers backwards. All right, how about let's try a couple more. So these problems using substitution method, you kind of need to take a look at each equation. See if we can kind of reduce them a little bit. So my first line, 3x plus 3y equal to negative 9, all three term is divisible by 3. So I'm going to do that first. So I'm basically just rewriting my first equation as x plus y equal to negative 3. All right, my second equation, all three term is divisible by 5. So I'm going to make my equation look a little bit easier to do. So that gave me 2x plus y equal to 2. So let's call this the original first. This is the original second, okay? So again, I got three variables with a coefficient 1, so I can solve any one of them. So how about this time, I'm going to solve for this x, okay? You can pick any one of three. So the steps are, number one, pick one variable out of the two equations, the one that has coefficient 1, and solve for it so we can substitute into the other equation. So I'm going to solve for x in first equation. So to get x by itself, this is positive x, let it stay there. So move the y, positive y over. So when I move the positive y over, I should get x equals negative y, positive y come over, become negative, minus 3. And let's call this equation number 1 prime. Because this equation come from my original first equation, and I worked on it one time. Now I'm going to sub my first equation prime into the second equation. And what am I subbing for? I'm taking these two terms, substitute for x. Right? That's why I solve for x, so I can substitute back into x, or substitute into x for the second equation. Okay, so my second equation normally says 2 times x. Now that 2 will times these two terms, negative y minus 3. two terms representing one variable or one thing, put them in the parentheses. Now the rest of my second equation says positive y equal to 2. So now once I finish substituting, you will always notice I only have one kind of variable I'm solving at a time. So let's do a quick distribution. 2 times negative y, 2 times negative 3. That gives me a negative 2y, negative 6, and a positive y equal to 2. Combine like terms, negative 2y plus y is negative y, all right? At the same time, what I can do is move my negative 6 over. That will become positive 6 on the right side. So 2 plus 6 will be 8. Divide both sides by negative 1. My answer, y equals negative 8. So once I come up with one answer, I can take that answer and substitute back to my first equation prime. I can technically go back to the original first two or the first equation prime. Okay, they're all the same thing. It's just easier to come back to this one where I already get x by itself. So my first equation prime normally says x equals negative y minus 3. Now you will say negative y. So I'm replacing y with negative 8, right? Be careful right here. This is negative 1 times x. Excuse me, negative 1 times y. So here I'm saying negative 1 times negative 8 minus 3. So be careful, okay? Otherwise we're messed up on the signs. Negative 1 times negative 8 is positive 8 minus 3, x equal to 5. So again, I got one solution, and my point of intersection for the two lines will be 5 comma negative 8. All right. So let's try to do the similar steps for this one. Okay, now my first equation, coefficients are 5, 1, constant term is negative 8. So they're not divisible by any number, so they stay the same. Now my second equation, 10 to 16, I can divide every term by 2. So let me write this down, okay? First equation, negative 5x plus y equal to negative 8. Second equation, now rewrite them as negative 5x plus y equal to, whoa, what just happened? Whoa, 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 whoa. Why is they the same? Why are they the same? They are the same because it's exactly the same line. So think about this. If I will get y by itself for both of them, you know what? Let me show you the step, just so you can see it one time. All right, let's solve for this y. Okay, write it down. The steps. Solve for y in first equation. If I get this positive y by itself, that means I'm going to move the negative 5x over. Remember now, I already said they are the same line because the two equations look exactly the same. Therefore, these two lines are the same. But if I go through the arithmetic, something's going to happen too. Move the negative 5x over, that's y equal to 5x minus 8. All right, let's call this first equation prime because now I'm going to sub my first equation prime into the second equation, right? Always go to the other equation. Now the other equation almost says negative 5x plus y. Now it will say negative 5x plus. I'm substituting my y in the second equation with 5x minus 8. So I'm basically substitute them for that position in the equation. So that will be plus parenthesis 5x minus 8 equal to negative 8. So second term has parenthesis. Plus sign here means I'm using a positive one dual distribution. So that will be negative 5x plus 5x minus 8 equal to negative 8. So when I combine like term, negative 5x plus 5x actually become no x's. 0x, the variable term is actually canceled out. So when the variable term cancels out completely, then what you're left with is negative 8 equal to negative 8. And that indicates the left side is equal to the right side. Or you can say that's one line equal to the other line. So when they are the same line, that means they have infinite number of solutions. They're intersecting everywhere. So let me go back here real quick and stove this. All right, so for this one, you will choose infinite number of solutions because they are exactly the same line. So infinite number of solution happens by the arithmetic. You will always notice variable term cancels out. What you're left with, left side is equal to the right side. That will be infinite number of solutions because graphically it represents they are the same line. All right. Let's look at another one. Oh, the first one, 4, 1, 1. Can't really cancel them out. So I'm going to just rewrite this. Negative 4x plus y equal to 1 is my first equation. My second equation, all three terms can be reduced by 2. So that's negative 4x. Ooh, this one's strange. Plus y equal to 15. So this one is almost like the previous problem we just did, except this part is slightly different. So if you just think about this, both of these y has coefficient 1. So if I solve for either one of those, that means I need to move the negative 4x to the other side. Moving the negative 4x to the other side will actually give me y equals 4x plus 1. The other one will say y equals 4x plus 15. So what does that mean? That means when two lines have the same slope, where the y-intercepts are different, that means the two lines are parallel. Okay. So parallel lines have no solution. So once again, I'm going to run through this arithmetic with you, okay? So earlier I noticed, the previous problem I noticed when the variable term cancels out, what's left of it, if the left side equal to the right side, is infinite solution. So here, for this example, my left side should be different than the right side, where my variable term all cancels out. So this time, tell you what, I'm going to solve for this y in the second equation. To get this y by itself, move the negative 4x over. That will be y equals 4x plus 15. I'm going to call this second equation prime. So now I'm going to sub my second equation prime into the first equation. What am I subbing for? I'm subbing for y in the first equation. So basically, I'm going to take these two terms and substitute for y in that spot. So the first equation says negative 4x plus y. Now you will say negative 4x plus parenthesis 4x plus 15. Still equal to what's on the other side of the first equation, 1. So again, second term has a parenthesis, so we got to distribute. This is plus, means positive 1 will do a distribution. So that gives me negative 4x, right? Positive 1 times 4x is positive 4x. Positive 1 times positive 15 is positive 15, equal to 1. So what happened again? Negative 4x combined with positive 4x, my variable term is gone. So that leaves me with the left side, 15, is equal to the right side, 1, which you know 15 cannot equal to 1. So that tells me the left side does not equal to the right side, or one line. Okay, that means one line never intersect with the other line. Okay, they stays parallel. Okay, because there's no solution. This side and that side does not equal, so there's no solution. No solution leads to parallel lines. All right. I hope that kind of makes sense. because I'm solving equation, but in a way we're still thinking about the two lines. All right, let's see what happened with this one. Now this one, the first equation, none of the three term can be reduced. So the second one, none of the three things can be reduced. So this is a very classic substitution problem where one of the four variable has coefficient 1. If that's the case, then that's a variable you solve. So we're going to solve for y in the first equation. That means I got to move the negative 2x over. So that will say y equals positive 2x minus 26. Let's call this first equation prime, because this comes from the original first equation. The next step, I'm going to sub my first equation prime into the second equation. What am I subbing for? I'm subbing for y. So I'm going to take these two terms, that's what my y equal to, and substitute into the second equation for the y. So my second equation normally says negative 2x plus 3y. Now the 3 will not times the y, but times my two terms that was representing what the y is, which is 2x minus 26. All right, substituting two terms for one thing, put it in the parentheses, still equal to negative 30. All right, so my second term has parentheses, so we will do a quick distribution. So negative 2x is the same. Positive 3 times 2x is positive 6x. Positive 3 times negative 26 is negative 78, I believe. 3 times 6 is 8. 18 carry 1. 6 plus 1, yep, equal to negative 30. All right, left side I can combine like terms, so I'm going to do that. So that gives me 4x. At the same time, though, I know this is a positive 4x on the left side, so I'm going to make my variable term stay here. That means that negative 78 got to be moved over, become positive. So as you can notice, I'm beginning to eliminating certain steps, because the more I write on the video, the scarier this thing gonna look. So negative 78 come over, become positive. So that means in the calculator, I had a negative 30 here, right? When negative 78 come over, it become positive 78. So we say negative 30 plus 78, which give me 48. Positive 48. So when I divide both sides by 4, my answer x equals 12. All right. So what do I do with this 12? Now I'm going to take my 12 and substitute back into my first equation prime, because that one is the easiest one to go back to, because it already says y equal. I can take the 12 back into the original first and second equation, but this first equation prime was just easier. So I'm going to go back to that. So we're going to sub x equal to 12 back into first equation prime. So since the first equation prime normally says y equal to 2x minus 26, now you will say 2 times 12 minus 26. Substitute 12 for that x, which is 24 minus 26, so my y is equal to negative 2. So in this problem, my point of intersection, or my solution to the system, is going to be 12 comma negative 2. All right, so in this video we're talking about how to use substitution method to solve the system of linear equation. Okay, solving for one particular variable that has a coefficient 1, and whatever we solve for, substitute into the other equation. So once we're finishing substituting, the equation that I'm working with only has one variable at a time. Okay, so we cannot solve two different variables simultaneously. We can only solve one variable at a time. And once I find that answer for that one variable, then I'm going to substitute back into one of my original equations, or the one that I keep on labeling with the prime, to find the other value. All right, that will conclude this lecture video. Thank you for watching.